Let's look at a few more examples that deal with equations of circles. Write an equation for the circle shown. So remember the equation of our circle, x minus h squared plus y minus k squared equals radius squared. So what do we need? The center in our equation is h comma k, and the radius in our equation is r. So looking in the picture, where's the center of our circle? If you're not sure, if you can't just tell at the point that it's at, try to find the widest part of the circle going in one direction and the widest part of the circle going in the other direction, and where those two lines meet, that's going to be the center. So in this case, the center is at the point 2, 0, and the radius is the distance away from the center, so to a point on the circle. So this looks like 1, 2, 3 blocks away. So the radius is 3. So then we plug it into our equation. X minus 2 squared plus y minus 0 squared equals 3 squared. But of course we can write it simpler than that, so we do. We don't have to write minus 0, and we don't have to write 3 squared. So there's the best answer. Now sometimes you're going to be given other information and asked to determine if, well, let's read what there is here. Given the center and radius of a circle, determine if the point 2, 4 lies on the circle, Usually for these, it's helpful to have an equation. So remember our equation, x minus h squared plus y minus k squared equals r squared, and we'll plug in the information and get our equation. X is negative 2, so the x coordinate plugged in will make x plus 2 squared plus y minus 1 squared, and the radius squared makes 25. So if we're to determine if this point lies on the circle, remember these are the points that are changing, the points on the circle. So we're going to plug these into our x and y in the equation and see if it's supposed to be in the equation. So we're going to put the 2 in for the x and the 4 in for the y, and let's see if it works. 2 plus 2 squared, 4 minus 1 squared, 2 plus 2 is 4, 4 minus 1 is 3, 4 squared is 16, 3 squared is 9, and look at that, we do get 25, and it equals 25. So determine if, that's a yes or no, the point lies on the circle. Yes, the point 2, 4 lies on the circle. What else are we going to see? Write the equation of the circle that passes through the given point and whose center is the origin. What does that mean, the origin? That's the point 0, 0, the origin of the graph. Remember to write the equation of a circle, x minus h squared plus y minus k squared equals r squared. We need the center, got it, and the radius. We don't have that yet, so we've got to figure that out. We're going to do that by plotting the point on the circle that they gave us, negative 2, 3, and then remembering that that means the circle is doing something like this, and the radius is this distance. Now, we don't need the graph because we know that the radius means the distance between those 2 points, and we know the distance formula. But the graph is kind of nice to make the distance formula a little bit easier. So remember that r squared is equal to all this stuff right here, hk being the center. So r, h, and k are 0 and 0. So if I want r squared, that's going to be x, this is my x and this is my y, negative 2 minus 0 squared plus 3 minus 0 squared. This is negative 2 squared, 3 squared, or 4 plus 9, which makes 13. Now, ultimately, we need the equation. We don't need the radius. But we may be asked at some point also, how much is the radius? So the radius is the square root of our r squared, which is 13. Sorry, square root of 13. But what do we need in our equation? The r squared. So let's write our equation. X minus 0, which is just x, squared, plus y minus 0, which is just y squared, equals r squared, which is 13. And there you have it. Write the equation of the circle given two endpoints of a diameter. Well, again, if we're going to write the equation, let's remember what that looks like. You might like to just write it down every time. The equation of the circle. What do we need? Well, the center, because that's the HK part, and the radius, or the radius squared, ultimately. Let's see if graphing will help. -1, 1, 2, 3, 4, 5. And 1, 2, 3, 4, -5, 1, 2, 3, -3. So remember that these are the endpoints of a diameter. From here all the way to here, that's our diameter. So where is the center of the circle going to be? Because we need that. So if that's the diameter, imagine the circle is going something like that. Again, just a rough sketch. Because the diameter goes through the center, it's got to be halfway between. So sometimes you can visualize it and see, boom, right where that center is. But sometimes it's hard to tell. So halfway is the midpoint of the diameter. How do we do the midpoint? Average the x's, average the y's. So here's the x's, average those. -1 plus -5 divided by 2. Here are the y's, average those. 5 plus -3 divided by 2. -6 divided by 2, and 2 divided by 2, or -3, 1. There's the center of our circle. 1, 2, 3, 1. That looks like it from the graph as well. Now the radius. So remember, the radius is the distance from the center to any point on the circle. There's the radius right there that we have to compute. Now we could do it with the equation like we did last time, or we can do it the triangle way. If I make this into a triangle, this side is 2 units, this side is 4 units, and then do it with Pythagorean theorem. Remember, c squared equals a squared plus b squared? Well, the hypotenuse are c, and that's r squared, equals 2 squared plus 4 squared. So r squared equals 4 plus 16, or r squared equals 20. Again, we're not asked for the radius, we need r squared in our equation. So now we can write our equation. X minus the x coordinate, so that turns into plus 3 squared, plus y minus the y coordinate squared equals r squared. See, we're using our center and our radius. R squared is 20. And there's our equation.